All right, so let's move on, guys. So we just finished those transformations. Now let's talk about these problems right here. So examples for the jigsaw, I want to work them out with you together. It's nothing difficult at all. Just want to make sure that we understand the processes with cubed root functions and how to solve for their answers. So guys, there's a difference between a cubed function versus a cube root. So the cubed function is raising to the power of 3, and a cubed root function looks like this. What's the cubed root of something versus what is something cubed? Are we good? Okay. So know the difference. Problem number 1. Your goal is to get x all by itself by moving everything over that you can in the reverse PEMDAS operation order. Okay. What do y'all suggest I do first? Raise everything to the power of what? 3. If this was a 5, we would raise everything to the power of 5. Okay? But I want to make sure that you understand something real quick before we move on. Secretly, there is an understood 1 right there. So we need to make sure by the end of today that we are capable of writing this cubed root of 5x minus 1 in both of these forms. In form 1 and form 2. Y'all with me?
Still raising it to the reciprocal?
Yeah, because when we cubed, the way we just did, and that's what I want you to make sure that you learn, is cubing both sides means we just raise it to the power of 3 over 1. And the reason why I want to get you used to that right now is because it won't always be 3 over 1. It could be 3/5. It could be 5/3. It could be whatever.
Yeah, I thought it. Oh.
So right now this 1 is here. This 3 is here. Just like it, you know what I mean? As far as its equivalent. So now let's go ahead and raise the right side to also the power of 3. What's 4 cubed? 64. What do I have left over on the left side? 5x minus 1. What would I do next? Add 1. And then? And my answer is 13. And yes, you can check it if you want. There's only one parent function in our original equation.
Wait, why did you go down to 5x minus 1 and then 1/3 and then...
Because when I raised both sides to the power of 3, okay, so let me show you that. This raised to the power of 3 will cancel out this cubed root.
Yeah.
Those cancel out and they go away. There's no more powers surrounding 5x minus 1.
So where are you getting the 1
Oh,
over?
it was just another way to write it. Because remember when I said when I raised both sides to the power of 3, which is 3 over 1, this is the lesson I'm wanting you to also learn today.
This is the reciprocal.
Yeah, this
Yeah.
will multiply to become 1.
And then you brought it over to there.
So when I raised both sides to the power of 3 over 1, 4 to the 3 over 1 is still 4 to the third. So you'll still get 64. Okay? Questions? Okay, so let's move on to, we have a couple more examples before we go to lunch. Let's do this one. And this is why this is why I stress the reciprocals. Because these are the ones people tend to miss. Alright, let's solve for x. What do I do first? Divide by 3. So when I divide by 3, I would get x plus 1 raised to the power of 2/3 equals 4. You'll see what happened? We have to isolate the radical. We just did. It doesn't look like it because you don't see a square root. But if you wrote it with the cube root and stuff, it would look like this. X plus 1 to the power of 2/3. It looks like that over there. Okay? So what are we going to do? Yep, raise both sides to the power of 3/2. We're not multiplying. That's a big misconception. We're not multiplying both sides by 3/2 because then it would be down here as far as times 3/2. And that's totally different than raising to the power of 3/2. Okay? Now, I know we will multiply the powers on the left side, but again, please understand that you know what is happening. You're raising both sides to the power of 3/2. When we learn logs and exponentials, this will help if you understand it right now, okay? Because those can be difficult later on if you don't understand.
Cancel out to the six plus one.
Yep, those cancel out to 1. Because they're cancellation forms of 1, right? And then the right side. What's the right side equal? 8. Again, you can think of it as 4 cubed, which is 64, then square root to get 8. Or you could think of it as, what's the square root of 4? And then cube that answer, which 2 raised to the third power is going to be 8.
So basically when you have like a number and then like a fractional exponent, you would take whatever's on top and do that first, and then whatever's on bottom, you like take the root of that.
I would do the root first. Do the denominator first. Do the square root. So what we did just now to make it easier is I saw this 4 and I'm going to do that first. That's over here because the square root of 4 is 2. So I'm going to take that and then I'm going to raise it to the third power, which is then the numerator piece here, and that's how I get 8. Either one will work, but if you do the root first, it'll be a lot easier on you. Especially because these will be with no calculator. So guys, what's my answer? 7. 7 plus 1, 8. The cubed root of 8 is 2. Squared is 4. Times 3 is 12. It worked. Easy so far, right? Not too bad? Alright, so let's go to, we have 2 more problems. This is an earth science example. It says for the meteor crater in Arizona, the formula D is equal to the following. Relates the diameter D of the rim in meters to the volume in cubic meters. What is the volume of the meteor crater? So you're trying to find the volume. What can I plug in that they gave us? The diameter. You with me? So if I'm going to plug in the diameter, and it says, ooh, I overlooked this. I need to bring attention to that. It said the diameter in meters, and this is in kilometers. I have 1.2 kilometers right now. How do I convert kilometers to meters? I can move the decimal over, or just know that 1 kilometer is how many meters? 1,000 meters. And I'll multiply. Remember dimensional analysis? Okay? These will cancel to a form of 1. And yes, you're right. All I'm doing is moving the decimal 3 times over to the right. So I would get how many meters? 1,200 meters. So over here, I need to read that this was that D variable in meters. So I have 1,200 is equal to 2 times the cubed root of V over 0.3. What do I do next? Divide by 2. So I have 600 is equal to the cubed root of V over 0.3. You can do it with your calculator if you want. And you need to know the steps though. What do I do next? Cube both sides. So 6 cubed is like 6 times 6, which is 36, times 1 more 6 is going to be 36, 3, 2, 1. So 216 is 6 cubed. And I'm cubing You see what I'm saying? So if there's 2 zeros and I cube it, how many zeros will there be? There'll be a total of 6 zeros because you're cubing each of those. So you have 216, and then, here we go. I'll show you, I'll highlight it. This right here is one of them. You're going to multiply it by another. You're going to multiply it by another. It's like x cubed. You'd write it 3 times out. I'm trying to help you about number sense without the calculator. So then you have, what? Bam. Bam, 216 million. Okay? Is equal to V over 0.3. So if I multiply both sides by 0.3, there's my answer. You with me? 0.3 is the same as 3 what? 3/10. So if I multiply the sides by 3/10, this 10 can cancel with one of these zeros. And now I'm just going to multipy it by 3. So I have 18, 4, 6, 1, 2, 3, 4, 5. 64,800,000 cubic meters. Almost done. One more question, then we go eat. Questions before I go? Alright, so let's move on to our last question. It says, you can model the population P of Corpus Christi, Texas between the years 1970 to 2005 by this radical function right here. Where x is the year, using the model, I want you to tell me what year was there 275,000 people. Where do we plug in 275,000? P, right, as P of x. My y value is equal to 75,000. Wait, yeah. 275,000 is equal to 75,000 times the cubed root of x minus 1950. What do we do first? Divide by 75,000, right? So guys, right now, if you didn't know this already, you could divide both sides by what? By 1,000, right? If you divide both sides by 1,000, those go away. So all you're left with really is the 275 is equal to 75. I'm helping you with number sense. And then you just divide by 75. You with me? So I'm looking at 275 divided by 75, and you can reduce by, let's say, 25, right? How many 25s fit in the bottom? 3. How many 25s fit up top? 11. So that we have is the cubed root of x minus 1950. Almost done. Raise both sides to the power of 3. Here we go. That's 11 cubed, which is 11 times 11 times 11, which is Pascal's triangle 1331. And 3 cubed is 27. So this is equal to x minus 1950. And yes, you would just add 1950 to this left side, and there's your answer. You would be able to use a calculator with this. But I'm helping you because you need to develop awareness of fractions and things by hand. So many people miss these questions on SAT non-calculator portions because they don't get the practice with this. So yes, after I add 1950, you're going to get some kind of weird decimal answer possibly. Or with your calculators, can I do that real quick? What's 1331 divided by 27?
Wait, why do we have to divide by 27?
Because 3 cubed is 27.
49.263.
So 49.263. And if we add 1950, we get about 1999.3-ish with some more added on that.
Yeah, but it's just asking what year.
Yeah, it's asking what year. So
1990.
1999, right? It's like during 1999. So 0.3 is like 1/3 into the year. You see what I'm saying? And 1/3 into the year is like April. Alright guys, that's all we have. We will review very shortly when we come back from lunch and then immediately take the quiz.